Okay, so in part one of this parallelogram example, verifying Stokes' theorem, we showed that the flux of the curl of f across our S here is a parallelogram, which I'll draw in a second, was equal to negative 118. So in this video, we need to show that the line integral around the boundary of f, is negative 118, integrating my f function. So let me draw my parallelogram again. So here's my parallelogram at by P0, P1, P2, and P3. Now are the vertices. And in part one of this example, we found this R mapping, this affine transformation up here that mapped the unit square onto this. So now I have to find the positive orientation of the boundary here. And also RU cross RV is up here. That's a normal vector. So we have to decide whether that normal vector is sticking out of S that way or is it sticking into S. In this case, actually, since it's minus here, it looks like it's probably going into S. So that's the case. If you use this little figure to figure out the orientation, you put your head in direction of the normal vector, and your left hand should be pointing towards the normal vectors. So it looks like it's probably going to be this way, or a positive orientation. But I'm going to show you how to do without having to do that. We're going to work off the orientation over here. So what we're going to do is we're going to go around the D in the counterclockwise direction. So we're going to go around D in the counterclockwise direction like we did for Green's theorem. And I'm going to parameterize each of these, and I'm going to map them then under my R, and I'll map over to the positive orientation for my boundary of S here. So let's parameterize my C1 tilde first. So parameterizing, we'll get this. So we basically have our start point plus our end point minus the start point times T. This just reduces to T0. And now I'm going to map this under my R. So let's do that. It's going to define R1 to be R composed with R1 tilde. And my R is up here. So I'm going to put T in place of U. So that's going to be my U, and 0 in place of V up there. So doing that, we get the following. So we'll get this. So again, I'm putting in place of U, I'm putting T, so I'll put T there, and 0 in place of V, so it'll be T plus 1 on the first guy, so I got that. Putting T there, it'll be 5T, 0 in place of V, so it'll be 5T minus 2, and so forth. Okay, so that's going to map over to parameterizing part of the boundary over here. Let's figure out what part of the boundary we've gotten here. So let's look at R time 0 and time 1. So I put 0 in place of T up here. Here, here, and here, and it ended up being 1, minus 2, 3, which is my P0 point. Now let's put 1 in place of T. So putting 1 in place of T here, here, and here, then end up with 2, 3, 5, which is my P1. So therefore, our R1 is going from P0 to P1. So let's call that C1 up here. So I put my C1 here. And so R1 is a parameterization of C1. So now let's look at C2 tilde, and then we can map into R to find another piece over here. Okay. So parameterizing R2 tilde, or sorry, C2 tilde, I'm calling it R2 tilde. So it's going to be start point, which is 1, 0, plus end point up here, so that's 1, 1, minus start point T. So simplifying this, you got 1T. So now we're going to call R2 the mapping of this guy under R. Okay, so let me write down here. Okay, so my R2 then will be R of R2 tilde. So it'll be then R of 1T. That means my U is 1 and my T is equal to V, and this guy up here. So I'm going to put 1 in place of U here, here, and here, and then T in place of V here, here, and here. So let's do that and simplify it. So we get this then, so it'll be 1 in place of u, t in place of v, so it'll be 1 plus 4t plus 1, then going across to that. So simplifying this, we get this. Now let's look at time 0 and time 1, where we're at. Let's look at both of those. So putting 0 in place of t here, here, and here, you get 2, 3, 5. Putting 1 in place of t here, here, and here, you get 6, minus 1, 9. So this first one is P1, the second one is P3. So we're moving along this way from P1 to P3. So I'm going to call that C2. Okay, so I'll call it C2. We got 2 more to go now, so let's do C3 tilde first. Parameterize it, let's call it R3 tilde. Okay, so here's my R3 tilde. It's going to be our start point, which is 1, 1, then plus end point minus start point times t. So working this out, you get 1 minus t comma 1 over here. So now let's apply r to it, and let's call it R3. So we get this then, so R3 is then R of R3 tilde, so it'll be R of 1 minus t comma 1. So my u is 1 minus t, my v is 1. So up here I'm going to put 1 minus t in place of u, and then 1 in place of v. So let's do that here. So again, putting 1 minus t in place of u here, 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 1 in place of v here, here, and here, you get this. So simplifying this, we get this, guys. So now let's look where we're at time 0 and time 1. So let's put 0 in and put 1 in place of t. So doing that, we get a time 0 we're at P3 and a time 1 we're at P2. So it's moving along this way. Let's call that C3. So we'll call it C3 up here. So now we got one more to do. We'll do the C4 tilde, then we'll map it onto R. It's going to be this guy here. Okay, let's start doing that. So doing R4 tilde, it's going to be start point, which is 0, 1, so right here, and end point minus start point t. You can check it becomes 0, comma 1 minus t. Now we're going to map that under R. Let's do that. Look at this. R4 is R of R tilde 4, which is going to be R of 0, 1 minus t. So you're going to put 0 in place of u, and 1 minus t in place of v up there. So let you check when you do that, you get. So you get this. Then you can check at time 0, you're going to be at this P2, and at time 1 you'll be at P0. So we're going this way. Let's call that C4. Okay, so now we're ready to start doing the line integrals. So let me just summarize what we have so far. So to find the line integral of f around c, we'll do around c1, c2, c3, and c4. Okay, so we have 4 guys to do, so let's start doing each one. Let's do the C1 guy first. Okay, so line integral around C1 would be integral 0 to 1 f of R1 dotted with R1 prime. So let's write R1 prime here. So derivative of the first component would be 1, derivative of the second component would be 5, third component would be 2, so let me write it here. So I've written it here, I'm using the I, J, K notation, oops, should be K there. Okay, so let's keep going here. Let's look at now f composed of R1. So here's my f up here. I have a z, x, but now z is going to be 2t plus 3. You're going to put in place of z. X going to write t plus 1, and then same all the way across here. So let's do that down here. So we get this. So again, I put a z, that's my z value, times x, x is t plus 1, then plus 2x, x is t plus 1, minus y, y is 5t minus 2, plus y, 5t minus 2 squared k, dotted with our R1 prime. So it'll be, let's stop this then, so it'll be 1 times this guy, 5 times this guy, 2 times that. Let me write that over here. So I get this, so again, 1 times that, 5 times that. I simplified this part here because it's 2t minus 5t, so it'll be minus 3t. It'll be 2 minus a minus 2, so it'll be 4 there. And then it'll be 2 times this guy. So you just have to multiply this stuff out and combine like terms. So you can pause the video and work it out if you want, but I was going to give you the answer you get after you multiply it out and combine like terms. You should get the following. So 52t squared minus 50t plus 31 after you multiply this stuff out and simplify it. So then integrating this will be 52t cubed over 3 and minus 50t squared over 2 and 31t. So let me write it here. So we get this. So we're going to put 1 in place of t and then 0 in place of t. So let's do that. So working it out then, you can check, you end up with 70 over 3 is your answer for this one. Okay, so we've done the C1, now let's do C2. Okay, so integrating over C2 now, we need to find our R2 prime, so derivative of this would be 4 here, negative 4, 4. So I'm going to write it here, my R2 prime. So I've written my R2 prime. So using the ijk notation, I factor the 4 out, and then I can write it as 4 times I minus j plus k. Okay, now let's substitute into this guy. Well, you just mentioned, so my f's the same. But now the z this time will be 4t plus 5, the x will be 4t plus 2, the y will be minus 4t plus 3 when you plug into this. Let's write it here. So we get this, so that's my z is 4t plus 5 times x, x is 4t plus 2, plus 2 times x, x is 4t plus 2, minus y, y is negative 4t plus 3, that's j, and plus y squared, y is negative 4t plus 3, I should be squared in this, right? Squared, and dot it with our R2 prime guy, which I've written here. Okay, so simplifying this here is going to be 8 plus 4, so it's going to be 12t, and it's going to be 4, so minus, so let me write up here what you get. So that part becomes negative 12t minus 1. Okay, now let's do the dot product. So the 4, I'm just going to bring outside the integral. Then it'll be 1 times this guy, negative 1 times this guy, 1 times this. So let me write it over here. So after doing the dot product, we get this. Then we just multiply this stuff out here and multiply this out and combining like terms. So you can pause the video and work it out, but you should get this as your answer. You should get 32t squared minus 8t plus 18. Then integrating this will be 32t cubed over 3 minus 8t squared over 2 plus 18t, so right over here. So I get this, so you're just going to put 1 in place of t and work it out. I'll just give you the final answer so that you check the work. So it should be 296 over 3. Okay, so we're done with C2 now. Let's go on to C3. So 2 more to go, C3 and C4. So let's do C3 next. Okay, so our C3 will be this. So my R3 is up there. So let's first find R3 prime. So it's going to be negative 1, negative 5, negative 2. Let me write it up here. Okay, written up here. Here's my f function again. So I'm going to plug into this again. This time my x will be negative t plus 6. My y will be negative 5t minus 1. My z will be negative 2t plus 9. So let's plug in here. So doing that we get this. So again it's z x plus 2x minus y plus y squared. Okay, so let's simplify this part here. So I'll let you check if you simplify the inside part, you should get 3t plus 13. So now we can dot these guys. So it'll be negative 1 times this guy, negative 5 times this guy, negative 2 times this one. So let's do that. So doing a dot product, you get this. Then I'll let you check. You can pause the video and multiply this stuff out. I'll give you the answer you get after you multiply it out and combine like terms. So you get this after you multiply that stuff out. Then integrating this will be negative 52t cubed over 3, negative 14t squared over 2, negative 121t. So let me write that out. So we get this then. So then you're going to put 1 in place of t. So doing that, we get, so after you work it out and simplify it a bit, you get negative 436 over 3. Okay, so we've done C3 now, so we've got one more to do to C4, so let's do that now. So lastly, our R4 or C4, sorry. So my R4 is this guy up here. I did my R4 prime already, so the derivative of this guy would be negative 4i, this one would be 4j, this one would be negative 4k. Pull the 4 out, it'd be negative I plus j minus k. So now my z is negative 4. This is my z now here, and this is my y and my x. So let's plug into this now. So plugging in, I get this. So again, my z is the negative 4t plus 7 x, negative 4t plus 5 plus 2 times x, and so forth. Dot it with this guy. So I'm going to pull the 4 out. It'll be negative 1 times this guy, 1 times this guy, and negative 1 times this. Okay, let's do it. Oh, before I dot, just notice I'm going to simplify this inside here. It's going to be negative 8. So minus 4 is going to be minus 12, and that'll be 10. Minus a minus 6, so 16. Okay, now let's dot these guys. So doing that, we get to here. And now I'm going to, I'll let you check. You can pause the video, multiply this stuff out, and combine like terms. I'll write the final answer on here. So you end up with negative 32t squared plus 84t minus 55. So integrating this will be minus 32t cubed over 3. This would be 84t squared over 2 minus 55t. So I'm going to write it here. So we get to here. Then you put 1 in place of t and 0 in place of t. So the final answer then will be negative 284 over 3. Okay, so now let's summarize. Let's add all these results together and see if it ends up being the same answer as we got in part 1 of the video. So let's do that. So summarizing then, the line integral around c would be the sum of the 4 guys here. So it would be 70 over 3 to the first one, 296 over 3, negative 436 over 3, negative 284 over 3. Adding those, you can check it's negative 354 over 3. That simplifies to negative 118. And that's the same answer we got in part 1 when we did the double integral. So let me summarize. So hence we have shown that the line integral around the boundary of f equals the flux of the curl of f across S. They both equal negative 118, which verifies Stokes' theorem. So we're done. So we've shown the line integral equals the surface integral. Okay, so we're done.